Oh, my name is Hamish, but a lot of people sometimes like to call me 25 or Titty, but you know, let's come here, man. So, more than two non-parallel forces. You know, things which are parallel. These are parallel. Things which are parallel like these means they go forever, they never meet. These are parallel. Like these lines here, they're parallel to each other because they never gonna meet up each other. It's always gonna go forever and forever. So these are parallel lines. Okay, so we want to check two parallel forces, you know. So we have the force 1, force 2, and force 3. They all acting at object O. For example, I'm pulling here, the other guy is pulling up there, and this other guy is pulling this side. But the force 3 make angle 60 with the horizontal. So just quick, right? Let me just quick, man, you know. Show you something quick. So everybody knows from basic trigonometry, just in case you don't know trigonometry, there's a little tricky that we always use. We say to, so, ka, to. This is very, very important before we go to this question. You know what I'm saying? So, ka, to means if I look for the sine, I must take opposite of hypotenuse. If I look for the cos, so, ka, excuse me, this must be so, ka, to. If we look for the cos, you take adjacent of a hypotenuse. If you look for the tan, take opposite of a hypotenuse. You know what I'm saying? So what does that mean? Excuse me. For example, if somebody give me this, somebody give me a small triangle here, I'm coming there, right? Because you have to be fluent on this. This angle 30, okay, and this, let's say they say 5 Newton. Okay, so somebody's pulling this. Let's say I'm pushing a box, or I'm pulling the box, whatever. So I'm pulling the box. There's a box here, but if I'm pulling up there, I use a force to pull it, which is 5 Newton. You know what I'm saying? So if I pull using 5 Newton, now they will ask me like the same force. If I had to resolve this force, means the component. Excuse me, just a minute. Okay, this is a triangle here, right? So we have a box here, and somebody's pulling there. So this force here is 5 Newton. So this is a component of this force. Mean this is the fx, yfx, because look, this Cartesian plane, this is horizontal x, and this is vertical y. So this force, if I had to make it horizontal, means we're going to call it what? Force of x. So force of x always, look, this angle, let's say this is angle 30. Okay? So if I want to get force of x, look, the easy way to make, I don't want to go back and forth, the easy way, take this hypotenuse, what is hypotenuse? 5 Newton, and then say cos of this angle. This is going to give you fx. But for fy, say, take this hypotenuse, this longer end, and then which is 5 Newton, then multiply by sine of 30. So to get anything which is in opposite, take hypotenuse, multiply by sine of angle. But if you want to get adjacent, take this hypotenuse, multiply by cos of angle. You know what I'm saying? So that's how you do. So if somebody give me, for example, so now, excuse me, just a minute. So now, how did I know this? So using this tricky, you know, using this tricky here, how did I know it? Look, means if I want to get sine, look, sine of angle equal opposite of hypotenuse. What is my opposite? I don't know what I'm looking for. So let me say force of opposite, because sine equal to opposite of hypotenuse. What is my hypotenuse? This is hypotenuse. This, okay. This hypotenuse, this is opposite, is adjacent. You know what I'm saying? So if I want to get sine of angle equal to the opposite, what is opposite? This force here, I don't know. Fy over hypotenuse. What is hypotenuse? 5 Newton. And look, 5 Newton times sine. Oh, so if I cross multiplication, it's going to be Fy equal to 5 Newton times sine of theta. Means if you cross multiplication. So that's how I got this. So this is an easy way of doing it. You don't have to waste a lot of time in exam, you know. You know what I'm saying? Just say, oh, if I look for the opposite, means if I look for the vertical one, always take hypotenuse multiplied by the sine of angle, which is the same thing using SOHCAHTOA. Got it. Now let's go for the cos. So for the cos, I'm going to use the same approach. For the cos, just say take hypotenuse multiplied by the cos of angle. You know, hypotenuse. If I want to get f of x, take my hypotenuse, for this case is 5 Newton, multiplied by the cos of angle, which is 30 degrees. You know what I'm saying? Okay, now just 1 minute and I'll go back there, just a minute. Okay, let me show you one more example and then we go back there. So what did I learn? I learned that whenever I look for the adjacent, I must involve cos. But if I look for the opposite, it has to do with the sine. Okay? Now, let's check this example. Just a minute, I'll come back to the example to a question quick. So somebody give me stuff like this. Let's say, okay. Okay, now let's say this is 40 degree and this is 30 degree. Okay, somebody was pulling this by the length. Let's involve length. Let's say it's not but it's about force, so we have to involve force. But let's just say length. Let's say 4 meter, 40 meter, and this is 20 meter. Now they want to find the whole. Okay, so if I had to resolve this force, it's not force about length. For this case, it's length, but it has to be force, for example. Okay, let's say somebody's pulling this up. So that means this one here is adjacent. Adjacent. This is adjacent. So how do I get adjacent? We say adjacent, it has to be cos. Take a hypotenuse, which is 40, and then 40 meter, or you can just say 40, don't worry about the unit. 40 hypotenuse times cos of this angle. That's how you get your hypotenuse. That's an easy way. You know what I'm saying? If you want to get this, so now, which direction is this force? Look, if this force is going up, even this is going to go to the left. You know what I'm saying? So, let's say Newton, man. Let's say force. Let's leave this distance because now this is about Newton. 20 Newton, 40 Newton. So that means I can plug in the calculator, get the value. But we know this, let me say 40. Okay, let me write down here, excuse me. 40. Let's call this F1. Let's call this is F1 equal to 40 Newton. Let's call this F2 equal to 20 Newton. Okay, so F1x means F1x equal to 40 times cos, because this for adjacent. So this you can plug in the calculator for 1x, but for me I know what is cos of 6. Cos of 6 I think is square root of 3 over square root of cos of 30. Square root of 3 over 2 times square root of 3 over 2 by 2 1 by 2 20. So let's say 20 square root of 3 Newton. This F1x, but which direction this force going? Look, if this going up, so this is going to go to the left. Look, it makes a lot of sense. Look, if this is going up, if I have to bring it down, means the direction this force is going to be to the left. But anything to the left always negative, means this force 1 is going to be negative. So I must say negative and then I must say negative. You know what I'm saying? Now, let's get F1y. F1y means the force which is going to be moving forward is the same force but a component of this force, which is going to be this. So let's call it F1 because it's F1. Let's call it F1y. So I'm going to get F1y. F1y is easy, man. I'm going to say F1y. But I will say anything which is vertical is sine. Has to do with the sine. But you must multiply by the hypotenuse. So I'm going to say 40 and then sine of angle. Okay, so this is going to be 40. Sine of 30 equal to a half, which equal to 20. Half times 4 equal to 20 Newton. Oh, but which direction? If this man is moving to the left, but this guy is moving up. But come on, man, in a number line, anything moving up is positive. Anything moving to the left is negative. So this moving up, because look, it makes a lot of sense. If this moving this way, if I had to make it vertical and look the arrow, means vertical is going to be facing up. Oh, so this is going to be positive. Now, let's do the same game for this force here. Now, let me do this. Let me change. Let me trick a little. Let me change. Let's say this force is facing down. You know what I'm saying? It's facing down. So now we go. So we're going to say F2. So I'm going to have to find the component of this force. If this force is moving down this direction, and then we want to make it vertical, so which with the direction of the arrow? Of course, look, like, come on, man. If we make this way, means this is going to be that way. You know what I'm saying? So we're going to say, okay, so F2y, F2y, let's say F2x, let's start this direction. Oh, yeah, this direction, let's say. So if this force moving this way, if I want to make vertical, means if I want to make x components, you know what I'm saying? How it's going to be, look, this. If I make this way, means it's going to be x. F2x. So always have to take hypotenuse. You know what I'm saying? Hypotenuse multiply, since it's very horizontal is cos of my angle, which is 40. And they can plug in the calculator, you get something, but it must be Newton. This is not special, that's why I didn't get it from the head. But you can plug in the calculator, get something. 20 times cos of 40, 20 times cos of 40, 20 cos of 40. And then this is going to give you 1532 Newton. So this is going to give 15.32 Newton. 15.32 Newton. Excuse me, 32 Newton. Oh man, it's too dirty there, but you're gonna say 15.32 Newton. Now we want to get vertical. So now direction. We have to know direction. If this stuff is moving down like this, and if I had to make like this, look the arrow means it's going to be moved that way. So means this must be negative. You know what I'm saying? Now let's go F2y. So this is F2. Y means it's something either moving up or down. But if you look careful, this stuff is like this. So y means if you had a face down, look the arrow is going to be moving down. So we're going to say, oh, but we know vertical. Vertical meaning sine. Anything vertical is sine. So we're going to say we must take hypotenuse, which is 20, times sine, because vertical, of angle, which is 40. Okay, so now we're going to take calculator. But which direction? Look the arrow. If I put this way, it means it's going to be moving down. So it must be negative here. You know what I'm saying? So we say 20. Take 20 multiply by sine of 40, man. Sine of 40. Let's get quick, man. Sine of 40 equal to 12/86. 12.8555. So 12/86. Negative 12.86 Newton. Oh, this F2. Y. Oh, so this is how I get the component of this vector. So if I have to resolve this vector, find the component, means I know this F2y, which equal to this one, I can write here. You know what I'm saying? And this, what is the other one? F2x, also no. No. So I know all these x's. Okay? So this is how you get a component of a vector. Means these are vector, but for this case, we say vector is anything which has a magnitude and direction. Means this stuff has a magnitude. Direction is this angle. So now we're going to work how to get the resultant of a force. Resultant and direction means magnitude of resultant and direction of angle. So you have a little idea what's happening. Now, just a little thing. How if this force was going to be moving up? Let's assume it was moving up. You know what I'm saying? Let's say it's moving up now. Let's change a little bit. Excuse me. So the force, let's say, is moving up here. So if this force is moving up that way, excuse me, let's say it's not moving down here, it's moving up this way. So how are we going to say, okay, so now let's get, if it's moving up means, if I want to find the resultant of this, the component of this force, so this is going to be what? F2y, means the face component, which is moving up. But if this stuff is moving this way, and we want to get the component of this force, means, okay, man, what you mean? What you mean to say component? Look, man. If this stuff, let's say, moving this way, the component means the fx, let's say this is f, and this is fy. If this stuff is moving that way, means this is fx, and look, if I want to make vertical, means if this arrow is like that, means it's going to be like that. So these are components of a force. If I don't want to use this, I can use this too. You know what I'm saying? So that's how we call components. So the same thing here, components. Let's find the components of this. So it goes, okay, let's find fy. Fy we know is sine, but you must multiply by the hypotenuse. You know what I'm saying? So now we're going to say f2y equal to hypotenuse, which is 20, multiplied by the sine, because this is opposite. If you want to get opposite, you multiply by sine. Which angle? 40. Positive or negative? Look, this stuff is moving up. So if you have to make like this, means look at the arrow. This arrow is going to be facing up. So this must be positive. And then you plug in the calculator, you're going to get your value. Now let's get f2x. If this stuff moving that way, if you want to find the component of fx, means look at the arrow, man. So if you make like this, means the arrow is going to facing to the right. So to the right means it's positive, and if it's adjacent, means cos. So we must take your hypotenuse always 20, and then cos our angle equal to 40. So you can plug in the calculator, but the answer is going to be positive Newton, and this is going to be positive something Newton, because the force, so it must be Newton. So that's how you get like plus and minus. You know what I'm saying? So now we have the components, all these factors, of all these components of all these forces. Okay? Now these are components. So you have all the components. So if somebody say find the resultant, to get the resultant is easy. So to get the resultant, so that's what you say. You say resultant of a force of all these forces. You say, okay, this let me say summation of all the force of x square plus summation of all the force of y square. That's how you get the resultant. You know what I'm saying? This is how it's going to give you the resultant of a force. So this is the resultant. Now let's get it. So now let's go. So summation of Rx first before you go to square. What is summation of Rx? Means of fx. So you can say fx or x, fx. Get all the x's, add them together. Okay, what is the first x's? The first x means this force here, which we have negative 40 cos of 30, and then it gives us this. So you say negative 40 cos of 30, because this is the first fx. So you say sum of all the ffx means this means sum. Add all the ffx. What is the first fx? Means this negative 40 cos of 30. Okay, what is the other ffx? This, which is moving. Look, these are components here. But we say if this will move that way, this will move that way, which is going to be what? 20 cos of 40. 20 cos of 40. But it's positive because move that way. So plus 20 cos of 40. So this is going to give us summation of f of x. Okay, let's plug in the calculator. So negative 40, so negative 40, negative 40 cos of 30, cos of 30, cos of 30. And then we go plus 20 cos of 40, cos of 40. Okay, so this is going to give us negative 19.32. Negative 19.32 Newton. But what happened? This must be square. You know what I'm saying? Because we're going to come and plug. Or you can plug after that, no problem. So we have an f of x, summation of all the f of x, means add all the f of x. Now let's get sum of all the f of y. So sum now of all the f of y. Let's get sum of all of y. Okay, now let's go for the first one. The first one, f of y, this one here. 20 Newton. This one means the one which is moving up. 20 Newton means 40, or you can say 40 sine of 30. And then let's go to the second. So we add because we want to get a sum. This meaning sum here. Okay, let's get sum. Okay, now, let's go to the next one. F of y. Okay, that f of y is on 20 sine of 40, which is positive. 20 sine of 40. 20 sine of 40. So 20 sine of 40. So sum of all f of y equal to, take a calculator and then add it up. So say 40, and then sine of 30, sine of 30 equal to half. 40 times half equal to 20. Okay, so this is 20 plus, so this is going to be 20 here. So 20 plus 20 sine of 40. So plus 20 sine of 40. Oh my God, excuse me, so sorry, just a second. Okay, 32.86, 32.85, so 32.86. So all this stuff together, all these and put in the calculator is going to be 32.86 Newton. So we have sum of f of x, f of y is going to come there, sum of f of x is going to come here. So this is going to give us the resultant of the vector, like what they ask for magnitude of the resultant. You know what I'm saying? So now we're going to say, okay, our resultant magnitude equal to, take this one square, f of x square means negative 19.32 square, and then take this one going to be 32.86 also one square, and then plug this in the calculator. It's going to give the answer. So now let's go. So square root bracket, okay, negative 19.32 square, and then we plus bracket 32.36. Okay, 38.1118. So let's say 38.12 in approximation. So if you approximate, our resultant equal to 38.12 Newton. So you have already get the resultant for this one. I'm coming there. You know what I'm saying? I want you to understand what is what is happening with this. Okay? So you know the resultant. So to get the direction, so this is like when somebody says the resultant for force. So that's the resultant of force. Now let's get the direction of force. Direction is easy. Direction of the resultant. So this is what you do. Direction of the resultant. You say angle equal to tan inverse. So this one is the resultant. So direction, you say angle tan inverse of this sum of fy over sum of f of x, which I have it already, man. You know what I'm saying? So I'm going to say, oh, my direction equal to tan inverse. What is sum of fy? Sum of fy we have, which is 32.86. So this is going to be 32.86 over negative 19.32, and these direction equal to, so take a calculator, say shift tan of bracket fraction 32.86, and then divide by negative 19.32. Shows me, close it quick. Okay, we got, so we got negative 59.54, negative 59.54. So these are our angle. But you know, you can add by 180. You know, whenever you get negative angle in tangent, add by 180. So I'm going to say, if you get negative angle in tangent from the general formula, always add by 180. But for sine and cos, add by 360. Okay? But this is tan. So the angle we get from the tan. So for that case, since it's negative, only when if it's negative. So we got this one, add by 180. Okay, so 120. So if you add this by 180, why add by 180? Like I said, because it's negative. But if it's just positive, let's say 20 or 30 or 60, leave the how it is, okay? Don't change. But because it's negative, so for that case, add by 180. So when you add by 180, this is going to give us 120. 120.45 degree. So this is the direction of the resultant. So now this is not part of the question that you want me to do. So now I'm going to come back here. It's going to be easy now because you know what's happening. You know what I'm saying? So now let me just erase this stuff quick. And let's go to our business. Okay? Now it's easy, man. Let's go. So, you know, it's all kind of math, man. Okay, cool. So first and foremost. Okay, cool. Let's go. So first and foremost, this one is called free body diagram. Free body diagram. Just in case if you don't know, it's called free body diagram. Okay, this is a free body diagram. Okay, now let's go inside this. Okay, cool. Now, so first and foremost, I'm gonna have to resolve this vector. Okay, let's resolve. So this is a free body diagram. Free body diagram. Free body diagram. Okay. Now, so now what I'm gonna do? I have a lot of forces here, but we have a force 2 equal to 20 Newton. And a force 3 equal to 40. Force 3 equal to 40. Oh, this is 40 Newton. Oh, okay. I got it. 40 Newton means the guy who's pulling this, he pulled the 40 Newton. This guy is pushed, is pulling also. He's pulling with the 10 Newton. 10 Newton. And then what happened? And then we have another force 20. So we have all the forces here. So we want to get the resultant. If I'm pulling, you're pulling, another guy's pulling. What is that resultant force we're looking for? It's easy, man. So now we're going to do the same game. Let's resolve. If this force moving this way, okay? Now let's resolve because we need the component of a vector. Look, I'm going to say, okay, so if this one move this way, if I had to find the component here, look, means this is Fy. Why? Because move, okay. You think it's going to move up or down? It must move down because look, it's like this. So if I had to make vertical, means it's going to be like this. Okay, so this equal to, remember it's opposite, like vertical. So vertical, we know is sine. So I'm going to say 40. So this I'm going to say F3x equal, I don't know if you can see that. So, let me write all this here, all this resultant, all these components of effect. Okay, I can write here, I think it's going to be enough. Okay, so this is going to be this F3y, because vertical, equal, is it positive or negative? Look, if this half move this way, means this one is going to be negative, because look, down, so it's going to be negative. So we always take hypotenuse, because this hypotenuse, man, look, even the triangle by this hypotenuse, which is 40, and then sine of 60. Now, we want to come here. If this man is facing, if this man or women facing this one, this king or queen, so if we come here in the horizontal, look, let's make it horizontal. It's going to face that way. So we're going to say F3x equal, so that way is negative always. Negative, and then we say 40, always hypotenuse. And then since the horizontal is cos of angle 60 degree. You know what I'm saying? So now we're done with it. So now we want to go for F2. So F2, look, is already y alone. You know what I'm saying? All exiting y. So this one here is like, it doesn't have like angle or something. This is like a y. Okay? So F2y, okay. Okay, now, let's write here. It's going to make a lot of sense. Let's start to the F1. F1x, look, F1x means this force is only horizontal. So it's like saying, if it was here, I was going to say, oh, map down, but it's already straight. So F1 horizontal is like saying, this F1, which is 10, and then cos, because it's horizontal. Cos of what? Which angle? 0, because this is like only line, so it means there's no angle. It's like if I put these two pen together, means there's no angle. Means this stuff is like, is on here. Means there's no angle between x-axis and this force. So cos of 0. And why I say cos? Because it's horizontal. You know, we just did it before. So now cos of 0 equal to 1. So cos of 0 equal to 1, so it's like say 10 times 1, because this equal to 1. 10 times 1 equal to 10 Newton. So F1x equal to 10 Newton. Now let's go F2x. F2x. But why am I doing this? Because I want to get the resultant. You know what I'm saying? Which says, if you want to get the resultant, you must find the sum of all the f of x in the u square plus sum of all the f of y in the u square. And the u square, this is going to give resultant. So I want to find all the f of x and then sum them. This represents sum. Okay, cool. So let's get the second f of x. Okay, F2. What is F2? This F2 is vertical up. So it does not act like, okay, so we're going to say, okay, so for that case, I'm going to say, what is F2? 20. But it's like this way. So meaning, it's going to be what? does it have anything with the x? Look, it's like this. It doesn't have any angle with the x, means if I had to make it horizontal, means it's going to be angle 90. Like, look, make it horizontal angle 9, angle 90. So I'm going to say cos of 90. But what is cos of 90? Cos of 90 equal to 0. You know what I'm saying? Cos of 90 equal to 0. Okay, so this is going to be 20. Oh, no, 0, excuse me. 0 times anything equal to 0. So this is 0 Newton, F2x. Because look, it's facing up. So if I want to make it horizontal, it's going to be, it must turn angle 90 because this is angle 90. Okay, now 0. Now let's go F3x. F3x. Okay, what is F3x? Okay, this is F3. So if you want to put x, we already got it. Means it must be hypotenuse times cos of angle because horizontal is cos. So, and where does it face? It faces to the left. So it's going to be negative 40, just like how we did here, cos of 60. Okay, so you can plug in the calculator if you want. Negative 40 cos of 60. Okay, negative 40 cos of 60. Okay, negative 20. This is going to give us negative 20. So this is going to give us negative 20 Newton. Even this one, you know, cos of 60 is special angle, which I have. I don't know, what's a lot of time. So we have f1x. So now we can get summation of all f of x. And then I'm going to go for y now. So summation of all the f of x equal, let's add all of them, 10 Newton plus 0 Newton plus negative 20 Newton. And this is going to give us negative 10 Newton. So sum of all this equal to negative 10 Newton. So summation of all f of x equal to negative 10 Newton. So we do the same thing for f of y. And then after that we finish, we go. Okay, cool. So f of y, let's do this. So f of y, so we want to get summation of y. So we'll say f of summation of f of y equal to f1y plus f2y plus f3y because they're 3f. Okay, now let's go. What is f1y? What is f1? F1 means this force here. But if I want to make it vertical, because y means must be vertical from the Cartesian plane, we know. You know what I'm saying? Y means something must be vertical. So if I take this and then I want to make like that, means it's going to be, which angle is going to turn? 90. But where is going to face? Look. It's going to face what? Up. So it's going to be positive. But what? If it's facing up, it's going to be, if you want to make up, means sine. Okay? So it's going to be 10, because if you turn like this, 10 sine 4 of 90. But what's sine of 90? Sine of 90 equal to 1. Sine of 90 equal to 1. So f1y, just a minute. Okay, hold on. We take this, we make like that. What am I thinking here, man? Come on. Okay, there is a way. Look, man. There's no y of this. It's only x's. So it's 0 because look. You know why I say 0? Because look, this f1, but there's no something in vertical. Okay. So meaning it's just a 0. F1y means we don't have f of the y. It's only on x. You know what I'm saying? It means this f1, but we don't have in y. It's only on x. Now we go f2y. What is f2? F2. This one we have equal to 20. You know what I'm saying? Just 20 Newton. 20 Newton. Okay, now we go for f3y. F3y we have it already. We did. Because say this face that way means if you want to make a vertical, it must be like that, which is going to be negative 40 sine, because it must be hypotenuse, which is 40. Okay, which is 40. Okay, 40. And then hypotenuse, which is 40, and then multiply by, since it's opposite, must multiply by sine. Sine of 60, angle 60. But since it's facing down, look, means it must be negative. So we have f1, f2, and f3. So we can add them together. Now let's go. So now we say, okay, so now we say we want to get summation. So summation meaning summation of fy equal to 20, 0 plus 20 plus negative 40 sine of 60. But what's sine of 60? Sine of 60, sine of 30 equal to half, so sine of 60 equal to, come on man, it's equal to 3 over 2, I think so. Okay, so plug in the calculator. So this is going to give us 20 plus minus 40 sine of 60. Sine of 60. Okay, so this is going to give us Summation of y equal to 20 minus 20 square root of 3. But let's put it in SD. Negative 14, excuse me. Negative 14.64. 0.64, yeah, to this one plus neutron. Okay, so we got summation of fx, we got summation of y. So now we need to square them, we need to get the resultant. So now the game is over. Let's plug it in here. So the resultant equal to square root. Let's get the square root here quick. So we have all f of x and we have all those f of y. Okay, what is the f of x sum? Negative 10 square, and then with plus. Now this is going to be negative 14.64 also must be square. So now if you plug this in the calculator, this is going to give you you can plug in calculator. Okay, so plus 100, excuse just a minute, the answer. Okay, 17.73. Oh, okay, so the resultant after you square root everything goes 17.73. But if you want to approximate, you can say this equal to 18 Newton, but I'll rather leave like this. So either way, it depends on if it's multiple choice, then see which is going to be the closer answer or the better answer. But if it's a written, I'd rather go right that way. Okay, so we have already the magnitude of the resultant. So that's a magnitude. What does magnitude mean? Magnitude is like when you say that Newton. I mean, it's a force, but it's a Newton. You know what I'm saying? But if it's a wind, it means it's blowing, so it must be velocity, which is kilometer, velocity or speed, which is kilometer is velocity, by the way, because it must have a direction. Wind is blowing southeast, so south, so you know what I'm saying? So that's a magnitude when you say velocity of kilometer per second. You know what I'm saying? Or acceleration meter per second square. But for this case, our resultant is Newton. So 17.73 Newton in approximation 18. We're done. Now we want to go for the second one. What is the direction? Come on, man. This is more easy. So easy the bottom, easy bottom of the basement. So now we want to get direction. Direction is easy. Direction means angle. So we say, oh, our direction equal to tan inverse. Okay, take summation of f of y always over summation of fx, which we have all of them. So we're going to say now direction equal to tan inverse. What is summation of fy? This one here. Negative 14.64 over summation of fx, negative 10. So plug that in the calculator and get our, okay, so shift to tan fraction, negative 14.64. Let's come down here, man. Negative 10. Okay, so we get 5566. Okay, so 5.66. You know what I'm saying? So this is our direction of the resultant force. Direction of the resultant force. Direction of the resultant force. I hope you learn from me. I hope you learn from a methodology. You learn from you know how I do things. You know what I'm saying? You learn from a lot of things from how I do things. I'm always speed, man. I believe whatever you do, you gotta force yourself. Okay? You know what I'm saying? All these, anything that I do, anything that you do, you don't just come by accident. It's all about hard work and put a work. Huh? Yeah. I'm out, man. Easy.